In this deep reality talk on cosmology, we'll explore the implications for black holes, dark matter, dark energy, the expansion of the universe, and the reasons we may be living in a big bounce universe. We begin with what's really inside black holes. In Deep Reality Talk 1, we discovered the two fundamental principles that underlie relativity and revealed the nature of the space-time fabric. 1. All processes in the universe have a total space plus time vector velocity equal to c, the speed of light. 2. Masses are fields of intrinsic spatial velocity in the form of minimal scale vibrations of space itself. Objects in gravitational fields feel the intrinsic spatial velocity of the field, which slows their velocity in clock time. So mass and energy are forms of spatial velocity, and all forms of spatial velocity are forms of energy. Refer to Deep Reality 1 for the details. Now, combining these two principles, we get a single universal principle that the total mass energy plus clock time velocity of every point in the space-time fabric equals the speed of light. This means that the fabric of space-time is a uniform field of c-valued velocity, which can take the form of either velocity in time or velocity in space. And any velocity in space is always some sort of energy. And energy always reduces the velocity in time. So their vector sum always equals c, the speed of light. This is why the presence of mass energy slows clock time. Now these principles immediately reveal what's really inside black holes. Black holes are now uniform spherical volumes of space-time with an intrinsic spatial velocity equal to the speed of light. They are the maximum possible density of mass and spatial velocity. And because the spatial velocity within a black hole is c, the velocity of clock time there is 0. So black holes are uniform throughout. There are no singularities at the center where the laws of physics break down, and there's no vanishing of mass out of black holes into another universe or dimension. These are errors based on the fiction of an infinitely compressible space-time. Now the atomic matter inside black holes collapses at least to neutrons, just as it does in neutron stars, because the intense gravitational pressure overcomes the mass deficit of protons plus electrons relative to neutrons, and all protons and electrons combine into neutrons. This is all the atoms in the black hole collapse to the size of their nuclei, and a black hole is essentially a single, huge, uncharged atomic nucleus. Now recall in the previous Deep Reality talk on time that the universal processor continually computes the universe as the three-dimensional surface of a four-dimensional hypersphere. The three dimensions of space are the surface, and processor time is the radial dimension stretching back to the Big Bang at the center. The processor continually adds ticks that lengthen the radius, and the surface gradually expands. This results in the gradual Hubble expansion of space. Now it's important to understand that the radius extends tick by tick in processor time, but the Hubble expansion of the surface is measured in clock time. So since processor time computes different clock time rates based on the amount of spatial velocity, and the amount of spatial velocity has enormously varied over the history of the universe, the surface has expanded at very different clock time rates. Now Deep Reality proposes a very simple and reasonable scenario for the expansion of the hypersphere. First, the Big Bang was an actualization event where the original particles of the universe actualized out of the quantum vacuum. Now recall from Deep Reality 2 that particle interactions create the dimensional relationships among particles that our brains simulate as spacetime. So as soon as particles appear, they begin to interact, and this automatically creates a spacetime large enough to contain them. The dimensional spacetime universe is born from the computational interaction of particles. Now assume for the moment that the particles initially have enormous heat energy. We'll explain why later on. Thus their interactions cause them to fly apart at near light speed due simply to their momentum. So the initial expansion of space is enormously rapid. The entire universe expands at near light speed spatial velocity. This drops the overall clock time rate of the universe to almost nothing. Thus the initial enormous expansion takes almost no clock time at all. This initial enormous expansion is called cosmic inflation. Now the fact that the overall clock time rate was almost zero makes it seem that inflation occurred almost instantaneously in clock time, when actually eons of processor time ticks were computed. So inflation actually took an enormous amount of processor time, but almost no clock time at all. This is consistent with inflation expanding the universe from essentially nothing to cosmic dimensions in less than a second. Thus the radial processor time dimension lengthened to cosmic dimensions even as almost no clock time passed. The radial dimension of the hypersphere grew at a rate much faster than its clock time rate. In this view, inflation was due simply to the momentum of the enormously hot interaction of Big Bang particles and nothing more. There's no need for an unknown inflaton field to explain inflation. It's simply that the slowing of clock time to almost nothing makes it seem to have occurred almost instantaneously. Now over time, the expansion of the universe gradually slows, and as expansion slows, the average spatial velocity of the universe drops, increasing its overall clock time rate to what it is today. Today, the Hubble expansion of the current universe is enormously slow, and only measurable over vast cosmic distances. This means the lengthening of the radial dimension is also enormously slow. Now the processor runs at an unimaginably rapid rate, far faster than the fastest particle interactions, because it computes them all. So tick by tick, the processor extends the radial dimension at an unimaginably rapid rate, but each dimension is unimaginably minute to account for the enormously slow expansion of the surface. So in this model, the entire expansion of the universe is due simply to the original momentum of the Big Bang. That's it. A very simple and reasonable theory that seems to explain the facts. Now, the initial enormous lengthening of the radial dimension of the hypersphere during inflation means the age of the universe in processor time ticks is enormously older than its 14 billion clock time years. This means the entire universe is enormously larger than the observable universe within the particle horizon. And this means the curvature of the three-dimensional surface is extremely small. And this is consistent with current measurements of the curvature of space that indicate it's very nearly flat. So this aspect of deep reality leads to the testable prediction that space has a very slight positive curvature, and that the actual size of the entire universe is vast and is measurable from its curvature, including the size of the unobservable part beyond our particle horizon. Now there's also an apparent very slow accelerating Hubble expansion attributed to dark energy. But first we need to understand dark matter and how that works. Dark matter is as necessary to explain the apparent missing mass of the universe revealed by the unexpected rapid rotation of the outer arms of spiral galaxies and the strength of gravitational lensing. The amount of dark matter necessary to explain this is about 5 times the amount of ordinary matter in the universe, a very large amount indeed. Current theories of dark matter all propose new types of particles beyond those of the standard model, but deep reality suggests a much simpler and more reasonable explanation that seems to fit the facts quite well. In their standard treatise on gravitation, Meissner, Thorne, and Wheeler explain on page 719 that the Hubble expansion of the universe is uneven. Only the empty space between galaxies is expanding, but the space within galaxies is gravitationally bound and doesn't expand. This obviously means there's an uneven expansion of the fabric of space around galaxies, which is precisely where dark matter is required to explain their rotation. Now, an uneven expansion produces warps in the fabric of space, and warps in space are precisely what gravitational fields are. So the uneven expansion of space produces additional gravitational fields around galaxies that explains the dark matter effect. This very simple and obvious explanation of dark matter I proposed in 2013 has additional advantages as well. First, there are no particles involved, so it's automatically dark and unobservable, except for its gravitational effects, just as dark matter is. Second, it doesn't require any new particles outside the standard model, so no new physics is required. And once dark matter masses are produced, they can move under gravitational forces just as galactic masses can, which explains why dark matter is found in other areas near galaxies as well. This new dark matter theory is testable by simulating the movements of galaxies in dark matter fields. Dark matter should be observed being initially created around galaxies and then moving around under gravitational forces. Now note the very interesting fact that if this model is correct, the amount of dark matter in the universe continually grows at a slow exponential rate, because as dark matter is created, its additional gravitation leads to ever more warping of space as the universe continues to expand. And this is in fact consistent with recent evidence from the European Southern Observatory, suggesting that the amount of dark matter in the universe has greatly increased over time. Now this theory may or may not account for the entire dark matter effect, but given the enormous expansion of the universe since the Big Bang, the uneven expansion of space should be producing a huge gravitational effect. So it's not the dark matter effect, what else could it be? Now if the amount of dark matter is increasing with time, this has some very interesting implications, because it means the total gravitation of the universe is increasing, which should eventually slow its expansion. And it also suggests that the current apparent accelerating expansion of the universe could be an observational illusion. And if this is true, then dark energy may not even exist. This boils down to how the rate of expansion is measured. Type 1a supernova all explode with the same brightness. Thus their apparent brightnesses can be used as standard candles to measure their distances. Next, their redshifts are used to measure the rate at which they're receding from us. And this is used as an indicator of how fast space at that distance in the past was expanding. Then by comparing the apparent recession rates at various times and distances, we get a picture of how fast space has expanded over time. And the picture that emerges seems to indicate that the expansion of space has been very gradually accelerating over the past 5 billion years. But if the amount of dark matter, and thus the amount of gravitation, is increasing over time, this creates a problem with the measurements, because the space we see closer to us has existed longer and will have denser dark matter gravitational fields on average. Now light takes longer to traverse stronger gravitational fields because it has to travel their curvature. This means that light from standard candles travels further than their nominal distances closer to us, so there'll be a slightly greater gravitational redshift as the standard candle light traverses the space closer to us. That will be mistaken for a very slightly increased, more recent Hubble expansion. As a result, more recent Hubble expansion rates will seem to be greater than they actually are compared to earlier ones. And this effect in itself could be sufficient to make it seem like an extremely small acceleration is occurring when it actually isn't. In other words, dark energy may not actually exist, because it could be an observational effect produced by the ongoing increase in the amount of dark matter, increasing the average gravitation closer to us in time. Whether this is enough to eliminate the extremely small dark energy effect is unclear, but it should at least reduce it. The jury's still out and further study is needed. Now, while the hypersphere is a very useful concept up to a point, it's extremely important to understand that the observable universe is not a physical hypersphere, nor is the hypersphere even actual in the sense that it's an independently stored data structure. The hypersphere is actually the emergent structure of the entire network of dimensional relationships among particles when viewed at cosmic scales. All the actual data of the universe is stored as individual particle values, including their dimensional values. There is no stored hypersphere that exists anywhere. However, when all the dimensional relationships among all individual particles are viewed in aggregate, they assume the emergent form of a hypersphere, since the gravitational attraction of all masses in the universe curves its overall geometry into a closed hyperspherical surface. Now, emergence is easy to understand by analogy to a TV screen, where the actual data is only the individual pixel colors, and the show emerges from the relationship of all the individual pixels in aggregate. In the same way, the entire observable universe is an emergent structure that emerges from the data interactions of all individual particles. Just like the show, it's actually only the individual values of its elemental data, and the whole picture emerges only to an observer able to see it in aggregate. So all the particle interactions in the universe create the entire emergent structure of the universe, bottom up, following the elementary rules of the complete fine-tuning operating over evolutionary timescales. So the observable universe consists entirely of individual particle data, and the hyperspherical data, the hypersphere is a structure that emerges from the relationships of particle data in aggregate. Specifically, this means the hypersphere is not an independent causal structure in which the continual extension of the processor time radius causes the dimensional surface to expand. This is just a convenient fiction that makes some things easier to visualize. So there actually is no processor time radius at all. The three-dimensional surface is a valid emergent structure, but the form of its cosmic geometry derives from the overall scaling of particle interactions by the presence of mass energy. It isn't directly expanded by the passage of processor time. The emergent space-time surface is just created large enough and in the correct closed hyperspherical geometry to contain all the particle interactions that create it. So the passage of processor time continually recomputes the surface, but doesn't physically create a radius that expands it. This enables us to understand how the continual passage of processor time can compute an observable universe that eventually begins to contract in a possible Big Bang or Big Bounce universe. Now, if dark energy is in fact an artifact of the increasing amount of dark matter and doesn't actually exist, or even if it does exist but is weaker than the exponential increase in dark matter, this leads to a very interesting conclusion. Basically, from the beginning, the universe has expanded simply as a result of the original momentum of the Big Bang, which means its rate of expansion has gradually slowed from inflation to the current enormously slow rate of the Hubble expansion. However, the continuing expansion gradually increases the amount of dark matter formed by the uneven expansion of space surrounding both galaxies and previous dark matter. So the total amount of gravitation in the universe continues to grow at a slow exponential rate. Eventually, the increase in gravitation overcomes the expansion stops, and the universe begins to contract. And as the contraction proceeds, gravitation becomes more and more concentrated, and the universe begins an increasingly rapid collapse towards a single universal black hole. So at some point in the future, the universe collapses into a single universal black hole that swallows all the atoms in the universe, converting them to neutrinos. And since all the space-time in the universe is maintained by particle interactions, the entire dimensional universe outside the universal black hole collapses into it and vanishes. The universal black hole is a volume of uniform c-valued intrinsic spatial velocity in which clock time comes to a stop. As a result, all particle interactions cease, and since particle interactions hold compound particles together, all the neutrons in the black hole dissolve into their quark gluon plasma. Now, interestingly, This instantly converts 99% of the gravitational mass of the universe into pure heat energy. This is because the total mass of the quarks and gluon components of neutrons is only 1% of the neutron's mass. The rest of neutron mass is due to the incredible spatial velocity of their quarks and gluons. So the net effect is that at least 99% of the mass of the universe is instantaneously converted into heat energy in the most enormous possible nuclear explosion. This conversion of 99% of the gravitation of the universal black hole into heat energy instantly creates a new white hole Big Bang. Clock time restarts and a new universe begins expanding through a new cosmic inflation and Hubble expansion until it too creates enough dark matter to reverse its expansion and collapse back into another universal black hole white hole transition. In this way, the universe continually undergoes big bounce cycles that presumably continue forever. This is a wonderfully imaginative and potentially testable theory based on two perfectly reasonable mechanisms that automatically create big bangs and gravitational collapses in a never-ending cycle. Now note that only a universal black hole produces a new white hole Big Bang, because spacetime is maintained outside individual black holes by myriads of particle interactions. So spacetime only collapses into a universal black hole when all the particles of the universe fall into it. And since clock time has stopped within the black hole, this allows its internal spacetime metric to collapse as well, including the dimensional structures of compound particles. Only at this point can neutrons dissolve into their elemental quark-gluon plasma. And this is what converts the gravitation of the universal black hole to an equivalent amount of pure heat energy that provides the momentum for the expansion of the next universe. Now, the gravitation to heat transition also resets the maximum entropy state of the universal black hole to the minimum entropy state of the ultra-hot Big Bang, which solves the problem of how the initially minimal entropy state of the Big Bang could possibly have originated, a problem that's troubled Penrose and others. This concludes the deep reality talk on cosmology. Much additional detail can be found in my book, Universal Reality 2.0. In the next deep reality talk, we'll discuss the amazing consequences of emergence and information cosmology. So stay tuned and subscribe to stay informed.